So, on the bench today we have this thing. It's an old telephone bell, and sort of thing you'd have on a house, outside the house, maybe extension bell, so you could hear the bell and the phone ringing in the garden. And the story behind this was, I was out on my bike yesterday. I was planning a grand tour of the Cotswolds on the electric bike. Anyway, I got about 8 miles from home and the bloody handlebars came loose, which is not something you want. In other words, they were swivelling and the brake levers were moving up and down, as it were. And this whole, I know this is diverting from the bell, but anyway, I was about 8 miles from home. So I thought, shall I go on or shall I abandon it and go home? So I was planning about 20-25 mile ride. But I did press on for a mile and they were getting looser and looser. I've done 200 miles on this bike and never had a problem before, but the moral of the story is take an Allen key with you. Anyway, I was about 4 miles away from a friend, so I thought, well, I'll ring him. So I rang him, he didn't answer, so I thought, well, I can probably get home, but I'll stop off anyway because it's on the way back at his place. So he rang me back a few seconds later, said he was in, fine. I went round there, got there, no problem. It's only not too far away, 4 miles on a dodgy bike, it's not too bad. And fixed the bike. Then I stayed up there for about 2.5 hours with doing various electronics or watching somebody else program an Arduino for a light controller. And somebody gave me this bell to look at, and this guy runs rinky-dink sound system, pedal powered sound system, creates music with a pedal powered generator, and it has various light effects on it and other contraptions that make it exciting and interesting for the general public. I think he kind of would have liked to put this bell on it. Well, this is, the whole system basically runs on 12-14 volts, and of course this is an AC bell, and I was under the impression they ran on about 50 volts AC at 25 hertz. But the other guy up there knows a lot about this stuff, said no, it's 100 volts. But whatever. I've managed to make these old bells work on about 50 volts before now, just running AC into them. So anyway, I brought it home on the back of the bike, and I thought it would be nice to try and make it work on 12 volts or 14 volts DC. So I was trying it this morning, and I connected it to the variac and wound the voltage up, and it, apart from vibrating a bit, it didn't ring, and I got all the way to 240 volts and it still didn't work. Okay, I was using 50 hertz, maybe it would have preferred 25 hertz, but so I didn't know what to do with it then. But the plan was to bring the circuit over. This is what I was planning to do, is build a 25 hertz oscillator with a 555 in its astable mode. And oh, it's so different now to what it used to be like. I just went on the internet, and there's a design calculator. You can put in the various frequency you want, capacitor, resistors, until you get what you want. And of course these two resistors change not only the frequency but also the duty cycle, and really I want 50%. The best I could manage with the calculator is 52%, and that would be fine. And this should, in theory, oscillate and produce a square wave at 12 volts output. Then I was going to drive it into a FET, and really I should, FET's really like a resistor in there, you know, something like 100 ohms or a K or whatever. Drive it into a power MOSFET anyway, and then from there drive a transformer in reverse. In other words, a low voltage secondary transformer and step it up, so you're using the primary to connect to the bell, and that diode is just to prevent the MOSFET blowing up with the back EMF, although I'll probably blow it up anyway, it's quite possible. So it's just an N-channel MOSFET driving a transformer in reverse, and so that brings me on to the next bit of it, trying to find a transformer that would work. And I found, oh by the way, this bell, I've normally found they've got a resistance on the winding of about 2k, 1k, something like that, but this one's really high. It's 4k, so that's obviously why it didn't work on, well, 240 volt mains, but it may have been the frequency as well, but that's beside the point. But what I want to do now is I want to use my function generator, which I've got set to 25 Hertz, and the amplitude is 10 volts peak to peak. And I'm going to drive this little transformer, which is down there, and those two wires are on the secondary. No idea what voltage this transformer is, and this is the primary winding of the transformer. So first of all we do it with no load on it, to see what we get on the scope. I'll connect the scope up to it and turn on the function generator, and this is a sine wave going into it rather than the square wave that I would get from my circuit. But you know, once it's been through the transformer, it may turn out to be more like a sine wave than a square wave. So we're getting rather a funny waveform, but that's not really important. What we do need to know is that what are we actually getting out of it. And if we look down there, I'm getting 364 volts peak to peak. That's quite a lot. 91 volts. 91 volts RMS. So that sounds about reasonable to drive a bell, assuming the 4K load doesn't load the bell too much, doesn't load the transformer too much. And of course the function generator is probably going to be fairly loaded. In fact, I can go on the primary, which is really the secondary normally, and see what it looks like on there. Well, there's not a lot on the primary, which is connected to the function generator. Okay, it's holding up fairly well at 40 volts peak to peak. I'm supposed to be putting in 10 volts peak to peak, but there we go. And I'm getting 3 volts, 3.48 volts RMS output. So the transformer is not loading the function generator too badly. So now I need to turn it off, otherwise I'll get a shock off the those two wires if I try and touch anything. Those two wires are fairly dangerous at the moment. So I turn that off and connect the bell up to it. I've now got the bell connected to the output of the transformer. That's fairly impressive, I think. Let's have a look on the scope. Let's see how much voltage we're now getting with the load on there. Okay, I was getting 45 volts RMS, so I think that's more or less what I expected, because I've always found those telephone bells that work on about 50 volts. I always thought that was the ringing voltage that came down the phone line, because I know you can get a belt off it if you touch it. Not enough to kill you or anything, but you get a fair shock off them if the phone rings while you're playing around with the wiring on a phone line. So now I've got to build this circuit up and see if I've got any 555s. I should have one somewhere. So I'll go ahead and get the breadboard out and try and wire it all up. Okay, so I could only find one 555, so I was lucky to find that. And that one had been severely abused by me by the looks of it. Fair bit of solder on it, but anyway, that's the whole circuit wired up. Well, not the whole circuit, just the 555 bit of it. So let's go over to the scope, and it seems to be working very nicely. Let's zoom in a bit. It's a nice looking square wave. I wish this thing would stop moving. Yeah, it's a nice looking square wave, and if we look on the what we're getting peak to peak of 14.4 because I'm feeding it with about 14 volts. And frequency 25.7 Hertz. You can't say fairer than that, can you? 25.7 Hertz with any old bottom 10 microfarad I happen to have. And duty cycle 49.3. That's not far off 50, so that I'd say that's pretty good. So the next bit to do is to wire in the rest of it, which is finding an N channel FET and connecting it to the transformer. Right, that's the rest of the circuit wired up. 1k resistor feeding the gate of the FET from the output of the 555. Anti whatever diode goes on the drain, which is also connected to the transformer, and the other end of the transformer is connected to positive. So what I need to do is we could look on, no, we won't look on there, we'll look on straight on the output of the transformer, see what we're getting. I don't know whether the FET's going to get hot. It may do, may need a heat sink. So let's turn it on. That is too big to measure, would you believe? And it's drawing about half an amp. Too big to measure. Well, it'll go down once you connect the bell to it. That's a big voltage, that is, because my probe's on ×10. So, okay, it's now working fairly well after a lot of messing around. Originally I was having problems that the peak current on when this MOSFET was switching was upsetting the supply to the 555 and causing it all sorts of trouble. So I got around that by sticking a 62 ohm in series, and the actual 12 volts fill 12 volts. Actual 12 volts comes in there, feeding the FET and the transformer, and 62 ohm to decouple the nastiness I was getting on here. And now it's dropped the voltage down by about a volt at that point, but it's nice clean supply for the 555. So I'll give it a try now. And it does seem though that it's drawing quite a large current on its peaks. The FET gets quite warm, but that can be bolted down. The transformer also gets quite warm, but I don't think this is going to be used continuously. I think it's just like you'd use a bell on a bicycle, because his machine is made out of bicycles. So I'll just undamp the bell because it was doing my head in, and turn the power on. That's enough of that. But the current, as you can see, is only 2 amps at the moment. That's interesting because it was knocking the actual voltage down on the power supply, suggesting it was going over 5 amps. Now it seems to be fairly steady and it's still vibrating away. But looking on the scope at the output waveform on the output of that transformer, it's too big to measure, and it's a load of pulses. I mean, I'm on 100 volts per division on this scope, so dear, that's about 1,000 volt peaks or something. But it works. That's all that really matters. I think that all I've got to do now is put it inside the box and bolt the FET down. The FET itself is touchable at the moment, so it won't really need much of a heatsink. But I'm going to turn it off now because the transformer's melting. Okay, so here's the finished thing, and made up a little board with a Vera board. I know it doesn't look very nice, but it doesn't have to look nice. It's just the fact that it'll work. Transformer's gluing down. MOSFET's down there. Haven't bothered with a heatsink. Just bolted it to the plastic. But it doesn't really get that hot. And as I said, I don't think it'll get used for very long. So the final thing to do before I put the top on it is just give it one more test. Turn the power on. Yeah, I had it in the wrong position, but it works, that's the main thing. And what was it drawing again? Probably about just over 2 amps. So that was a quick, rough and ready video on how to make a old telephone bell work on 12 volts, and it probably could have been done better and with a less complicated circuit, but it works. That's all I can say. So bye for now.